Okay. Hi, my name is Alex Storm. My project is going to be about hashing. At the end of this presentation, I'll be demonstrating a small dictionary attack using Python. Now, hashing is a process of converting an input of any length into a fixed size length using a mathematical function, meaning that any array of text, no matter how long, can be converted into an array of numbers using an algorithm. Okay. Now we're going to be talking about the hashing process. The process of hashing consists of three main parts. First is the message to be hashed, which is called the input or pre-image. Hash functions are deterministic, meaning that if the function is the same, a hash function will always produce the same output. So you would essentially get a password or a plain text and you would put it into the hash function or algorithm. From there, you would take it there and then you would make it into a hash text or a digest or an output. Now, hash functions always produce a fixed output size. However, for different hash functions, they will have different output sizes. Now, what I mean from that, an example would be if we put in the word cat and we put it through the hash function, it would create a four number output. However, if we put in the name, like say Lord, and we put it in through the hash algorithm, it would still create a four number output. However, since there are different types of hash functions, they could have different output sizes. So, for example, MD5, the digests are 128 bits, while SHA 256 is 256 bits. Hash functions are typically uniform, meaning that the output should be distributed evenly across output space. And cryptographic hash functions are one way functions, meaning the function is practically infeasible to invert, meaning that whenever you take a hash function, a plain text, and you convert it over to a hash function, it's very, very difficult theoretically for it to go back. Now we're just going to be talking about the different types of hashes. There are many different types of hashes, but we're just going to be talking about three right here. MD5 uses 128 bits, which I talked about earlier. It's known to be vulnerable, particularly to hash collision vulnerabilities, but it's still used today. SHA2 was developed by the NSA, and it's a cryptographic hash function. It's made of six hash functions with digests. I know that the SHA2 is not the only version of it. There are multiple versions. Like I believe there's a SHA1 as well. CRC32 is an error detecting code, and it's typically used for file integrity. It's not used as much as it used to be used. However, whenever it is, like I said, it's used for file integrity, so such as zip files and FTP servers. Now we're just going to be talking about early hashing. Hans Peter Lund was an IBM engineer that created numerous things in patents. He is credited with creating the first hash algorithm. In 1953, Lund had written an IBM memo where he suggested putting information into buckets to speed up a search. So, this information was regarding phone numbers. He wanted to assign each entry to pairs. So, he basically took the phone numbers and paired off each number. The digits from the pairs were then added together and a new number was created. The original information was put into a bucket and it was labeled with the new number. Over time, computer scientists have improved upon Lund's method. The method that I just described was actually what was considered the first hash algorithm. Nowadays, with the new hash algorithms, they're all different. However, the premise of what he initially made is still the same. Because of him, hashing algorithms have been crucial to cryptography, telegraphics, and telecommunications. He's highly influential in the computing world, and we have him to thank for the hash algorithms. Now we're just going to be talking about blockchains. So blockchains are actually dependent on hashing. Blockchains use hashing by hashing each transaction and bundling them up together. Each block links to the previous block, and that makes the blockchain immutable. The hash function will then produce a completely different hash if there's a change in any of the transactions. This results into an alter of the hashes. This actually makes it highly securable. That's why a lot of people are going into blockchain. They know that the money that they're putting in is secured. Different blockchains use actually different types of hashes. So I know for sure that Bitcoin uses SHA 256. So here we're just going to be talking about the types of attacks. So we're just going to be talking about a dictionary attack first, which is the type of attack that I use in the demo that I have after the presentation. So using a dictionary attack can show vulnerabilities within a hash function. Dictionary attacks tries a list of known or common passwords, and they just essentially try to match it up with the hash. They tend to succeed because many people choose passwords which are easy to remember. A lot of times, hackers will have these outputs and passwords from stolen files. And this process kind of seems a little impractical simply because it is just mixing and matching. But because of computer speeds, this can be actually done very efficiently. The second type of attack that we're going to be talking about is a brute force attack. This involves login attempts using every possible combination to guess a password. So these are typically used for smaller inputs, typically because the smaller the input, the smaller the combination to guess. However, with the longer the password is, the lower the possibility of this attack to actually succeed. But since a hash password output is typically a certain amount, you do still have the possibility of for this attack to actually succeed. It's a small possibility, but it still could happen. Now, for the third type, we're going to be talking about hash collision, which is an attempt to find two input strings of a hash function that produce the same hash result. And so we're just going to be talking about the breaches of hash passwords for the past year. Now, uh, for these examples, I have two examples. For one of these examples, they're actually going to be talking about the breach of a hash password. However, for the second example, we're just going to be talking about how a hash password could have prevented a breach of security. Now, one of the biggest data breaches that occurred in 2020 was the Wishbone data breach. Wishbone is a popular social media app that a lot of teens use, and in May, a group of cybersecurity analysts found that hackers were selling a database with over 40 million users. Their records and their data were then sold on the dark web. The experts pointed that the severity of the breach could have been limited if the data was properly encrypted. Wishbone at the time was using a MD5 password, and although they were using a hash password, hackers were able to decipher them. This particular case is a little disturbing, simply because it is talking about younger users. Younger users typically are more susceptible to these types of attacks, simply because they'll put out their information or their data onto the internet without really thinking about the security precautions that they may need to take with putting said information out on there. Just because they'll use a lot of social media apps or just apps in general. Now, the second scenario that we're going to be talking about is the Anthesis Technologia data breach. This occurred in March 2020, and safety detectives they revealed a breach for this biometric solutions company. The company had left data on an unsecured server. This data included around 76,000 fingerprints that were stored. The fingerprints were then saved in binary code, which hackers were able to steal. And they took this binary code and they were actually able to recreate the fingerprints. The reasoning behind this was the company actually neglected to password protect their database properly. Anthesis Technologia, they released a statement saying that they hashed their passwords. However, whenever they investigated this statement, it was actually proven to be false. So this would just be the example I talked about how if they actually had a hash password, they probably could have limited the breach um, that occurred. Now, I'm just going to be talking about why I use Python for this particular demo. Python is a high level programming language. It is open source and object oriented, and it has a great set of libraries that can be used for hacking. Python is also very easy to learn, and it's growing in popularity. I know that for a lot of companies, they're switching over to Python just for convenience sake. And now we're just, my references are right here. Now I'm just going to be showing you my demo. And for this particular demo, I'm going to be starting off with my hash generator. Now this is my hash generator. This is the hash generator I used. So I just Googled this up. I just put in MD5 hash generator. And how this generator works is you just type in whatever password or word that you want to use, and it'll generate the hash. So this would be the hash for cat. Now, whenever we're going through, I just went through here and I just put in just the list of hashes. It's just a small list right here. And this is a password list. And typically, for any hackers or users that will use this method, they typically want to have a large dictionary. So it's not uncommon to see one that goes from 100 to 1,000 words. The reasoning behind this is because the more words that you have, the more possibilities of you actually matching with the hash. So if you have a larger library, it would be great for you, just so that you can actually have that possibility of matching with the hashes. Now I'm actually going to go into the program itself. Now, to start off for this program, you will have to import a library. It'll be the hashlib library. To start off, we have to pass the hash through with an input. So we put in the hash here after we run it. And we're just going to actually have to pass through the file. So we're going to create a word list for this. And we're going to have to input what is the dictionary. So we're going to try to pass through the file like I said. And it's going to be a text. And we're going to open up the word list. And we're going to give it a read capability right here. I just put in accept just because, just in case I misspell anything, and I just need a way for it to actually like notify me that hey, no file is available. Then after, you're just gonna put a for loop, and you're gonna run the pass file through the for loop. So it's just gonna be using a encode word, and this is just a digest, aka the output, and we're going to just put a hash lib from the hashlib library, and we're going to make sure it's MD5 hash. And we're just going to run a if condition, and we're just going to put the condition is if the digest or the output is equal to the hash, then we'll be able to print out the password, aka the word. And we're just going to break it right there. So now we're going to actually run this code. So enter your hash. So we're going to put this in, and we're actually going to copy this and paste this.